Okay, today we are reviewing for the test, and this is a question about how to get a vertex. And I suggested that we instead change it to, there's like 10 questions I could ask you about this. I'm going to change it from how do you get the vertex to how do you get the discriminant. Discriminant is x equals negative b over 2a. True or false? False. Very good. What's that one do? The x of the vertex and the axis of symmetry. Good. Okay. It must be then that it is x equals negative b plus or minus square root b squared minus 4ac all over 2a. Right? That's not the discriminant. Just the b squared minus 4ac part is the discriminant. All right, so b squared minus 4ac, b squared is really negative 6 squared, which is 36. Minus 4 times a times c. The a is 1, and the c is 11. 36 minus 44, which makes what? Negative 12. Now, if all you said was that, you missed half the credit, because the discriminant problem is about getting the answer of negative 12 and then saying, therefore, what does this tell us? No solutions. The discriminant is negative 12. But that means that when you actually do the quadratic formula, negative b in this case would be positive 6 plus or minus the square root of that. It's not going to work because you can't have a square root of a negative. No solutions. Now, granted, you could also argue that there's imaginary solutions, but we're not going to go there for this test. Yes?
Isn't it negative 8?
Okay, let me double check on the math there. 36, 40, I think you're right. It's not negative 12. I did the math wrong. I think, did you say negative 8?
Yeah.
Let me double check that then. 36 and 8 is 40. Yes, you are correct. Thank you very much. Either way, it's negative. And, you know, I kind of zoned out once I saw it was negative. It didn't matter that much to me because it doesn't really matter that much what it is. If it's negative, I was jumping right to the, there's no solutions. So if it's negative 8 or negative 12, either way, there's no solutions. But you make a good point. All right, so now let's instead change this same exact problem to its original. What's vertex form? Oh, I think I'm going to use the vertex CTS. Complete the square. 11 moves over. Remember this kind? Pause for a second while you give that one a shot. Okay, so this is half and square. Half of 6 is 3. Actually, it's negative 3, but it's going to get squared anyway. Makes it positive 9, and then negative 9 is there to counteract it. This part gets factored. Y equals x minus 3 squared. That part gets added, plus 2. Your answer is that for vertex form. Raise your hand if you had that right. Good. Now, what if they had said, what is the vertex? Because that's not vertex. That's vertex form. That's not the vertex. Why 3 and not negative 3? Can't trust the stuff on the inside. That's a good way to say it. Okay, good. And is that vertex a minimum or a maximum? It's a minimum. It's a low spot because this is a U shape. Always make yourself a picture to judge that. Think to yourself, okay, well, I know it's going to be a parabola, and I know it's going to be, well, it's either a mountain or it's a U, and there's no negative, so it must be a U shape. And then you can say, oh, that's a minimum, the low spot. Okay, so what's another question we could ask you about this same exact thing? Find the roots. Okay, the roots would be the x-intercepts. But we did figure out already that this is going to have a negative underneath the square root. So do you really actually need to go try to find the roots? No, because we know it won't work. Okay, but that is a good question we could ask. And then to be extra tricky, we could say find the zeros. Same exact thing. Okay, good. Because his roots are the zeros. How about the solutions then? Same exact thing. How about the x-intercepts? Same exact thing. Okay, here's one more thing I could ask you though. Find the axis of symmetry. There's an app for that. the axis of symmetry. Okay, if you know it, write it down. Don't just give me a bald answer. Because if you know that you think the answer is 7, you'd be wrong because you can't just have a bald answer. All right, there's an app for that, and it goes really fast. We already did the vertex CTS. That's kind of slow. You move the 11 over, you do half and square, blah, blah, blah. There's a lot faster way. This. What's negative b in this case? 6 over 2a, which is, and that equals, we just found the x-axis. We found the axis of symmetry. And it's the x of the vertex. Do you get how fast that was? I already know the x of the vertex. It could be argued that you don't even need to know how to complete the square. Because to complete the vertex CTS finds you the vertex, right? Complete the square process. But so does this. It's almost done finding me the vertex, and it only took me like 2 seconds. I got the x of the vertex. How do I get the y of the vertex? Plug it in. Plug that into this. Everybody do that. Plug it in here and here. Figure out what the answer comes out to be. And I bet you'll recognize that vertex. You've seen it before. Stick the negative or the 3 into the equation. So did you get 3 squared is 9, minus 6 and 3 is 18, negative 18 plus 11, and these are always opposites of each other, so that's negative 9 plus 11 makes positive 2. Raise your hand if you got that right. Okay, good. So knowing that you can do it that way, unless they tell you complete the square, you can pick either way you like. It's like having 2 different tools in your toolbox. You can find the vertex CTS. That works. Or you can, hold on, or you can grab the x equals negative b over 2a tool, and that still gets you the vertex. Either one of them gets you the vertex. They're totally different. It's sort of like a reciprocating saw. That's a saw that goes back and forth like tick, 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 tick. Okay, so it looks like kind of like a gun that's got a trigger, and then the end of it just rattles like, okay, and you can use that to cut a curve like this, or you can use a saw called a, what did I use on this thing? Remember? It was a, it wasn't a sawzall. That's a reciprocating saw. The kind that, I can't think it just goes up and down. It's not a is it a jigsaw? Could be called that. There's another name for it though. No, that's where the bandsaw has a continuous blade that keeps going around in a circle. It's like that, but anyway, I cut off the edge of my desk with one, and I can't think of the name. The old name was coping saw, but then they weren't power. Anyway, the point is, I just named like 4 kinds of tools you could use to cut a curve like this. You have 2 math tools at least that can find you the vertex. In fact, you have 3 now. The very first time we found the vertex, do you remember this? I would say this spot is at 1 and this spot is at 7. And find the vertex. You remember that deal? And you go, oh, well, it must be on this line that runs here. What was that line called again? The axis of symmetry. You can find the axis of symmetry by just using this. It was good for you to know in the context of a graph, but now that you are a little smarter than you used to be, this is really powerful because it finds you the vertex or the axis of symmetry by just sticking in b and a into the little formula. All right. Let's arrow down to the next slide. This one's the same as the last one, so let's go to the next slide after that. All of a sudden, it's a little more complicated to do the vertex CTS. Now, just to clarify, you do need to know both methods for this test. But let's just for a second use the new way. What's that little formula again? And what does it find you? The vertex or the axis of symmetry. Good. Find me the vertex and the axis of symmetry using negative b over 2a. It'll be way faster than the complete the square. All right, here we go. Negative b over 2a is like negative 8 over 2 times 2, which makes 4, which makes -2. But I hope you didn't just stop right there, because that would have been the axis of symmetry. X equals -2 is a line at -2. But if you want the actual point, the actual vertex, you would then take the -2 and put it into point form and figure out the y of it. So you stick the -2 in here and there, and you get -2 squared is 4. 4 times 2 is 8, so that's 8, plus 8 times -2 is -16. Notice again, these are a half relationship, and ones, when they're all done, that's -8, and then -1 makes -9. Raise your hand if you had -2 comma -9. Awesome. Now that's one way. And I know you might think, well, I want to always do it that way for the vertex. But I'm telling you, you'll need to know how to do the vertex CTS also, because there's going to be problems where you have to use the complete the square method. So everybody move this -1 over. Then, if you can factor, you should, and then complete the square. You're going to get the same answer. It's just, can you complete the square? I'm going to pause for a second while you try that.
So what I did first is
I agree, factor out to 2. Then, okay, what's half and square on the 4?
4.
Excellent. And then? And excellent, and then? Perfect. Oh, I was hoping you'd remember this. Okay, go ahead. Yes, because this 2 has to multiply by it also to keep these balanced, and I bet some people forgot that. Nice job catching that. -9. And that makes sense because we already figured out the vertex on this puppy before, and it was -2 comma -9. Actually, maybe we didn't on this exact problem. My bad. It was something similar to this. Was it the same?
Yeah, this one.
Okay, cool. All right, so that's vertex form. Is the vertex on this one going to be a minimum or a maximum? Minimum, because it's a mountain shape. No, because it's a valley shape. Sorry. Valley shape. So it's a minimum because it's the bottom of the valley. Okay, good. Then, here is the hardest kind of all. You'll have to do half and square on a fraction after you factored it. Give it a try. This one is the one that separates the A's from the B's. You should have said the 6 factors out and you get x squared plus 3x. And then I have to do half and square. Half and square on a 3. Half of 3 is 1.5, but you should not use decimals because you're not going to have a calculator on this test. If you could, you just graph this on the calculator and it'd tell you the vertex like boom. You know what I mean? You graph it and go, oh, there it is. So you can't use calculators for this. So you don't want to use decimals. So in my opinion, you should say half by doing that. That's a way to say half. Divide by 2, right? And then squared means like that. That's half and squared. And if you square something, it has to come out positive, right? There you go. And then how about on the outside? Well, actually square it. It's going to be 9 over 4. And then this 6, you remember, the 6 has to also hit over here. 6 times that, and this one's negative. So there's a lot to remember there. Y equals 6, x plus 3 halves squared. How many got the first part right? Good, but that's the easy part. The hard part is the end part. If you haven't already done this, it's like 6 times 9 over 1 times 4, and it's negative, and then you have to subtract 1 from that. So you'll need a common denominator. Take a second, grind that out, and get your final answer. It's just multiplying fractions and subtracting things that don't have common denominators, 2 things from the top 20. This is why the top 20 was so important to get down before now, because then your life would be easier right now. You could get things like this right. Besides, those kind of skills come up as you move up into pre-calc also, and they come up on the ACT, and that's why I was such a pain about making you learn those. And some of you still haven't, but there's still time. The top 20 is going to go in the grade book again. You're going to have one probably this next week. And it'll be, here it is again, 20 questions, 20 minutes. So if you haven't learned them, go back and learn them. This is helping you to learn them, I guess. Did you get 9 times 6 is 54, over 1 times 4 is 4, and it's negative? You with me so far? And then you're subtracting 1 over 1, which is really like subtracting 1 over 1 times 4 over 4 makes 4 over 4. And then that makes negative 58 fourths. And could you reduce that and cut them both in half? Sure. Therefore, negative 29 over 2. There it is. That was an ugly one. But you know what? The other thing wouldn't have saved you. Negative b over 2a seems like it'd be way easier. But the numbers are so big. Negative b is negative 18 over 2a. Over 2a is 2 times 6 is 12. Negative 18 twelfths is what you get, which you then have to reduce. Makes negative 6. Wait a minute. 6 goes in there 3 times over 2. Negative 3 over 2. Negative 3 over 2. See? Same vertex. But then you'd have had to stick negative 3 halves into here and multiply it all out. It would still have been icky at the end. But we did it. All right. So let's go down a little ways and try. How do you get the roots? Isn't that the same thing as something else? The x-intercepts, the zeros, the solutions. So if you can factor it, you should. But wait a minute. Don't you have to do something first? All right. What if I add 12 to both sides? Then this becomes 0, right? And if it's set equal to 0, then if you can factor it, you should. But I'm telling you, it might be a little bit of a pain to factor this one because you got that negative in front. I'm not saying it's impossible, but it might be a pain to factor. What if you can't factor it? What always works? Okay, you need to repeat this after me. If you can factor it, what? You should. But what if you can't? If you can't factor, 2 words, quadratic formula. If you can factor it, you should. If you can't factor, say it. All right, good. So if you're able to figure out the factoring on this, bully for you, and you'll have the answer. If you can't figure that out, it's totally okay to just go quadratic formula it. Either way works. Give it a shot. Okay, here's what you should have been thinking on this one. We are at x equals negative b plus or minus square root b squared minus 4ac all over 2a. I personally am going to do it that way. I know it could be factored, but you have to factor it with that negative, and it makes it really complicated. So I'm just going to go b squared. Watch this. It isn't that bad. B squared is 16 minus 4 times a is negative 1 times c is 12. That's b squared minus 4ac. That's 16 plus 48. That's 64. Oh my gosh, it's going to work out nice because it's going to have 2 solutions. Do you get that that's what that tells you? B squared minus 4ac comes out positive. I got 2 solutions. And I can do a square root of it really easy. So now I'm going to go x equals negative b, which is negative 4, plus or minus the square root of 64, which is what? 8, all over 2a, which is 2 times negative 1, which makes negative 2. And so then my answers are x equals negative 12 divided by negative 2 makes positive 6. And if I do it with plus, negative 4 plus 8 is positive 4 divided by negative 2 makes negative 2. There's my answer, 6 and negative 2. I know if you could have only factored it, it would have been much easier, right?
Yeah.
So tell me the secret to the factoring. Yes?
Moving the 12 to the right, but moving the minus x squared plus 4x to the left.
I agree. Now just hold on a second. Here's the 2 answers, x equals 6 and x equals negative 2. Well, let's keep those on the screen here. But you just said you should really have actually gone the other way and put all this stuff over here. Why? Then the lead coefficient won't be negative anymore. then it'll just be positive x squared minus the 4x minus 12 equals 0. And then you can factor it really easy. And it's x plus 2 and x minus 6. I think that's right. Outside, inside, does that work? And then what are my two answers? Negative 2 and positive 6.
Wait, that doesn't work. It's negative x squared.
But we moved it to the other side.
Adding.
We added x squared to both sides.
Now would it be a maximum or a minimum?
That's what I was about to ask you.
Would it still be a
Wait a minute. So you're saying we just solved this equation right here. Notice there's no negative in front. As opposed to when we moved the other stuff over to the other side, when we moved the 12 over, we had negative x squared plus 4x plus 12 equals 0. What? So one of them's got a negative in front and the other one doesn't. Do you get in both cases they touched the roots at positive 6 and negative 2? The answer either way was positive 6 and negative 2. This way or using that way, the answer is positive 6 and negative 2. So at least they all agree on positive 6 and negative 2. Then the question is whether the parabola goes up or down. And that just depends on which one they gave you. What was the original problem? Did the original problem have a negative x squared in it? All right. The original problem can be rearranged, but only to find the roots, which are these guys. I found the roots either way, but then go back to the original problem. The original problem had a negative in front. So that means originally it's one of these guys. And therefore, the vertex, wherever it is a maximum. Go back to the original and see if there's a negative in front. That's the best advice I can give you on that. Because when you rewrite it, you're just either way, you're finding the roots. And we all agree on what the roots are.
So if it was negative x squared equals 4x minus 12 plus 12, would it still be negative?
Here's the thing. When you have it in this form, technically, what you have is two equations. Technically, you have two equations. You have this equation, and you have this equation. Technically, y equals negative 12 is a line that runs like this. And this, if I factored it, let me think the negative could come out, and I'd have x squared minus 4x, and then I could factor it. If you can't factor it, you should. X comes out, and then you have x minus 4. And then I know my roots on this one, well, this is really going to mess with your head, are 0 and 4. 0 and 4. And that one is a negative in front, so it's a parabola going like this. And where the two equations cross are here and here. Okay. But what did I tell you? Go back to the original. If the original problem has a lead coefficient that is negative, then I want you to think, okay, negative, upside down parabola, and therefore its vertex is a what? It's a maximum. Okay? Now that last thing I just showed you is not something you need to be able to do. I'm just trying to show you that it's true. Solving by graphing is so easy if you just graph this side and you graph that side. If you had a calculator, you just type in both sides and you say, where do they cross? Because that's actually what you're really doing. But the point is to find the roots of this equation. We always want to set it equal to 0. In this case, we could have gone either way. We could add 12 and make it this. Or we could have moved all the junk to the other side and equaled 0 the other way. And either way, you're going to get the same roots. All right, enough of that one, because I think it's only going to mess with your head further if I leave it alone. I think we'll be okay for now. Take a look at this one. See how it's negative in front? Will this one have a minimum or a maximum? This one will have a maximum because it'll be a parabola like this. And if I did the discriminant, b squared minus 4ac, it tells you how many solutions you will have. b squared minus 4ac. Okay? That's going to be 16 minus 4 times negative 1 times 12. Just a rough estimation in your head. Is this going to come out positive or negative? It's come out positive. Therefore, there's how many answers? What if it had come out negative? No answers. What if it had come out to be 0? And that answer is special. That one answer is the vertex. Yes. All right. So I think we should jump to the very last few things here. You remember how to complete the square? This is just half and square. So if I was going to do this, what number should go? This should not be an equal, sorry. That should be a plus. What number should go there to make it a perfect square? Half of 6 is 3. 3 squared is 9. Good. What number should go there to make a perfect square? Negative 3 over 2, but squared, and therefore 9/4. I agree. All right. And then the last one? You're just halving and squaring in your head now. This is good. That'd be 25/4. All right. On to this slide. What's that dotted line called again? Axis of symmetry. Isn't there an app for that? What's the thing for axis of symmetry again? Good. And what can it also find you besides the axis of symmetry? The vertex. Because then you'll know x equals like 4. And then if you want the vertex, it's 4 comma something. And you stick the 4 into the equation. Okay, good enough on that. Extra challenge. Find the domain and range of this. I'll give you a hint. The domain, super simple. It's a parabola. They all have the same domain. Whether it's this way or this way, what's the domain on that puppy? Negative infinity to positive infinity. Okay, good. So the only thing really that you need is the range. If you need the range, don't you need to know how low it goes or how high it goes? In this case, is it a minimum or a maximum? All right, because there's a negative in front, it's a high spot like this. So we need to find that high spot to be able to know the range. Because the range goes from negative infinity up to this high spot, and I don't know where it is. How high is that? We need to know the vertex, really. Do you get how the only real problem is, like figuring out what you want? I just need to know the vertex, and I'll have the range. It'll be easy. So do you have two different ways you could find the vertex? So you could either complete the square, ick, or what's the easier way? That's a little formula. It's not the quadratic formula. Negative b over 2a. That tells you the vertex. Do that on this one. And you'll know the x of the vertex. Then stick it back in the equation, and you'll find the y of the vertex. I know it's a fraction. And that's going to be what separates the a's from the b's on this one. Because it's negative 10 over 2a, which is 2 times negative 2, which makes positive 10 over negative 4, which makes 10/4, which makes 5/2. Negative. X equals negative 5/2. Great. You mean I have to go back and stick that into the equation? Yup. It's either that or do an awful complete the square. Either way would work. So see if you can handle it. Use those algebra skills. Flex those algebra muscles. Don't pull an algebra muscle. Mr. V, simplify this first term for me. Negative 2 times 25 over 4. I agree. Now I'll simplify it further. Can you do a little factoring on the top and the bottom? That might help you to get this done. What's the 4 factor into? Just a 2. Come on, 4 factors into, I think you're not catching what I'm trying to say. 4 factors into 2 times 2. Okay, why did I do that? Now you can cancel. Good. Cancel, cancel. Now what do I have? And don't forget the negative. Okay, that's the first part. Mr. W, take over this part. Front row, Mr. W. Negative 10 times negative 5 over 2. Okay, so we're going to make this negative 10 turn into a negative what times what? Negative 5 times 2. I can buy that. Now what? I like it. Now what? All right. Is that a 3? I think it's a 5. There we go. So negative times negative is positive 25, and that's it. Plus 25. And then the last thing is plus 7. Whew, 25 and 7 can add together. That makes 32. But now I got to add negative 25 halves plus 32. What I'd recommend is getting a common denominator. What's a good denominator? 2's, and therefore multiply this by 2 and this by 2. So negative 25 over 2 plus 64 over 2. We're so close. Finish it. 39, I'm going to double check that. 40, 50, 60, 4. You are right. Negative 39 halves. Yes? My bad. It was an adding problem. I was thinking it was a multiply problem. You're right. It's positive 39 halves. Anybody else verify that they got that answer? Okay, 3 people are agreeing that are pretty smart kids, so I'm thinking it's right. Okay, now that was a lot of work to figure out the y of it. I already knew, let's see, oh, that was the vertex. Okay, so what was the point of this question? Find the domain and range. We already knew the domain. Domain was negative infinity, positive infinity. So then what we were really doing was we were finding the vertex. So 39 over 2 is the y of the vertex. Whew. That means how high it goes. That means the highest it goes was 39 over 2. So that means the range of this thing was from what to what? And after all that work, I'd still have to mark it wrong. What did I do wrong? Bracket. Because it can touch there. Bracket on this. Can you imagine getting that wrong after all that work? All right. Your homework for tonight is the entire review worksheet and checking it. I strongly recommend you do both. This is going to be one of our hardest tests. If you can pull this off, you can have it nice and pretty easy till Christmas. Study hard tonight and this weekend. Have a great weekend. See ya.